This is the notes page for piecewise functions. We've looked at piecewise functions in Unit 1 where we just were given a graph. Now I'll graph one for you, and then we'll look at word problems, which is the main emphasis. So this is a piecewise function. The first part is f of x equals x squared, and that's going to be true when x is less than or equal to 1. The second part is 2x plus 1, and that's going to be what the function is when x is greater than 1. So at 1, the function is going to change from looking like a U to a line. And so when we look at this, it's important to remember that the domain for this, there's no restrictions on the x squared, there's no restrictions on x for a line, and here it's 1, so 1 is covered. So the domain is all real numbers, but the domain has been split. Okay, so when you want to graph this, you want to keep in mind that 1 is where the split occurs, so we'll put 1 kind of in the middle, and we'll pick some values to the left of 1, which would be 0 and -1 and -2, and then some values to the right of 1, which would be 2, 3, and 4. Okay, so we can pick any x's we want, and those are the x's I decided to pick, with the emphasis on 1 being in the middle, so I can see both pieces of the graph. If I started at 2, I would never see the x squared. Alright, and then I'm going to plug in, so when x is less than or -1, we use this function, is what this says. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared. 1 we would use, it says equal to 1, we'd use the top function, so we're going to use the x squared, so that's 1. Now when x is 2, x is greater than 1, you have to use the bottom equation, so that means when I evaluate x is 2, I have to use the second part of the piecewise, and I'll need to write it over here. So 2 times 2 plus 1 would be 5, and 2 times 3 plus 1 would be 7, and 2 times 4 plus 1 would be 9. And most people so far, that makes sense, but the key that you need to remember is that you have to evaluate this place where the domain is split for both functions, and I'll explain why when I graph. So we've already got when x is 1, y is 1. Well, now we're going to plug 1 in here and get 3, or 1, 3. Well, this says x is less than or equal to 1, so this is a point on the graph. This says x is greater than 1, so we use the word open boundary, Unit 1. This is what 1 is. 1 is an open boundary. It's a boundary, so you have to evaluate it, but it's going to show up in the graph as a whole. Okay, so now when we graph, we'll graph the order pairs -2, 4, and the order pair -1, 1, and 0, 0, and 1, 1. We'll also graph 1, 3. Alright, it's a whole though. And then 2, 5. And 3, 7. And 4, 9. Okay, and now we're going to connect the dots. Now this domain is all real numbers, so we have to make sure we put an arrow at the end, because we know this goes on forever and ever. And then we're going to connect the dots here. Now that's a complete graph. It's perfect. Now let's go back to, I said I'd explain it. Why do we have to do this? Well, if you forget to do this, then this is what your graph looks like. And that is not the correct graph, because you're missing points from 1 to 2. And we said the domain is all real numbers. So that's like saying that you can't put 1.1 and 1.2 and 1.3. So you have to evaluate this open boundary. You have to evaluate and get 1, 3, and that way now 1.1 is in the domain. When x is 1.1, y is 3.1, 3.2, so forth and so on. So that's the tricky part to graphing a piecewise function. Alright, so that's the graph of a piecewise function. Now we will look at some examples. I took this from the lab manual. It's currently lab manual number 3 in the piecewise section, and it's a word problem. According to the Bureau of Labor Statistics, the North Carolina unemployment rate for 2008 can be approximated by the function given below, where U of t represents the unemployment rate in percent and t is the month in 2008. Example, January 2008 equals 1. So I'm going to write down my Math English Dictionary as I do for every single word problem. T is month in 2008. So we can't put January in the function, obviously, but we can put 1 in there. Okay, so when we're working in the function, this is numbers. When we're interpreting, it's going to turn into months. And then U of t is the unemployment rate, and we're given it in percentage unemployment. Okay, then it says calculate U parentheses 4. That's function notation. Do you know what that means? Well, that means that when t is 4, what is U? Okay, so t is 4, and then now you have to decide which equation to use in this piecewise function. Do you use the top equation because it says t is between 1 and 9, or do you use the bottom equation because t is between 9 and 12? Right, you would use the first equation. So U of 4 equals 0.28 times 4 plus 4.44. Alright, and then we'll use our calculator. 0.28 times 4 plus 4.44, 5.56. Okay, so that is the value of U of 4, but then it says interpret. So remember, when we're interpreting just an ordered pair, it's kind of like an if-then or a when-then. So you have to take the 4, the input 4, and translate it into real world. Okay, 4 is the 4th month in 2008. Well, what month is that? All right, that's April. So in April 2008, this U is percent unemployment. So the unemployment rate was 5.56, and the unit is percent. That's right there. The next one, use functional notation to approximate the North Carolina unemployment rate for December 2008 and calculate that value. So now we're outside the function. We're real world. You have to know what to plug in. Well, December is the month in 2008. What month is it? It's the number 12. It's the 12th month. So you're trying to find U of 12, and it says use function notation. So there's my function notation. Now you need to figure out which function, part of the function to use, and it says t is between 9 and 12. Use the bottom equation. And we can use our calculator for that. .67. All right, and it doesn't say interpret, but we could add units. This is the unemployment rate, 8.67% in December. Next, when in 2008 was the employment rate 6.12%? So these two I call input-output problems. They're easier. They're what we used to call in my classes plug and chuck. We're given the input, we put them into the function. You can use a calculator, it'll spit out the output. But this one, you have to notice the difference. We want to know when in 2008, so we want to know what the input is when we know that the output is 6.12. So these make it, with piecewise functions, this is a little bit harder. You have to think. you have to figure out which one do I use. Now some people can just do a little bit of thinking based on these answers and figure out which one, but it's safer just to try both. Okay, so the first function, the top part of the function, 0.28t plus 4.44 equals u, would be this equation, and then we would solve it. So if I subtract 4.44 from both sides, 6.12 minus 4.44, I get 1.68. And then if I divide both sides by 0.28, t equals 6. So what do you do with this? Well, we've solved this equation for t, but what we have to do is you have to check this against this domain here. So the top equation, the t values can only be between 1 and 9. Is 6 between 1 and 9? Yeah. So that works. And then we have to answer the question. The answer really isn't 6 until you think about it. T stands for months in 2008, so that would be June 2008. That's the answer. All right. But it possibly might be another one because the we know that this is a line, but it's possible that when you have an output-input, you can have more than one answer. So we have to check the other one too. 0.8t minus 0.93 equals 6.12. I'm going to add 0.93 to both sides and get 7.05. So 0.8t equals 7.05. Divide by 0.8, and t equals 8.81. And you have to check your work. So check it against the domain here. So this second equation, this t value is only going to be correct if t is between 9 and 12. Is this t between 9 and 12? No. Okay. So you have to check both of them. These output-input problems, you have to try both of them, or at least think through it to see. And it's possible that they both might give you the answer, so be careful about thinking if you got the answer the first time, it won't be necessary to check the second one. All right, let's look at the second example. Okay, so in 2017, the federal income tax rate for an individual with income from 0 to 9325 is 10%. For gross incomes greater than 9,325 up to 37,950, the rate increases to 15%. A says express taxes paid T as a function of the gross income I. Sketch and label the graph of T of I. So this one is asking you to write your own piecewise function. Okay, so first of all, this is supposed to be a hint. This is T is a function of gross income I. So I'm going to write my Math English Dictionary. I is my input, and it's gross income, and it's in dollars. And then T is taxes paid, also in dollars. Okay, so according to this function, if we know the gross income, we'll know the taxes. Okay, so we want to make a piecewise function, T of I. That's the function notation. And we've got two equations. Now I'm going to do 4 lines. 1, 2, little if here, 3, 4. Okay, so there's 4 things that you need to tell me, and you want to go backwards. The first thing is a little easier for students is let's figure out where the domain got split. The domain for this problem is all real numbers, unless, yeah, it's not all real numbers because it starts and stops at a certain point. But you want to look for where your income is split. And right here it says income is from 0 to 9325. You got this percent. and then if income is between 93.25 up to 37.950, you get this. So your income, we're talking about I, this is your input, this is the domain. The income is between 0 and 93.25. So it's easier if we just write something called a combined inequality, and it looks like this. And I'll move my hand out of the way. Okay. So here we're saying that I has to be between 0 and 93.25. I is greater than or equal to 0, and I is less than or equal to 93.25. Okay. Then we want to look at the second split. I is between 93.25 up to 37.950. Okay, and it says greater than 93.25. That's important. Okay, so it's between these two numbers. Okay, now let's look at think about the equal to. We already said that if I is equal to 93.25, see that equal to, you use this top equation. So we cannot use a less than or equal to. We can just use a less than there, because also it says greater than. So if we read this backwards, I is greater than, open mouth, greater number. I is greater than 93.25, but it's also less than up to, so we get to include that. Okay, and I said it was all real numbers. The first couple of problems were all real numbers, but this one we have a boundary. The real world domain is from 0 to 37.950. But it's split right here at 93.25. Okay, so the first thing you want to do after you define your variables is to think about the domain. Now what we need to do is write the two equations. So let's go back up here and see if we can write an equation for this part. The federal income tax rate with an individual with income from 0 to 93.25 is 10%. So now I need to take a time out and review percents with you. Okay, if you are given the number 10%, you should always think, well, 10% of what? Right? What is the income tax rate? It's 10%. 10% of what? If someone told you your income tax rate is going to be 10%, you should think 10% of income. It's never a percent never stands alone. It's always a fraction of something. So this equation is just going to be, the other thing you want to do is you don't calculate with 10%, you should change it to a decimal. So that's going to be 0.10 times your income, which we've defined to be I. Okay, so that's it for that first equation. Second equation, for greater than 93.25 up to 37.950, the rate increases to 15%. Now this is a little tricky. It was tricky for me the first time I ever read this, and I won't never want to forget it. I messed up. But now I've seen it so much I know what to do. So I'm going to tell you what to do every time. Alright, so here's what a lot of people do is they'll put 0.15i. But that's not what's happening. So what's happening is you get to pay 10% up until 93.25. Okay, so what you have to do, and I'll make little notes here, is you have to find the total. You have to total out the top equation. So let's figure out what 0.10 times 93.25 is. It's 932.50. Okay, so that's going to go here. That number is the total from equation 1 plus, okay, so that's the first tricky part. Then you got the 0.15, 15% of what? And here's the second part. People make mistakes. Sometimes people just put I. Well, that's shooting yourself short. You've already paid this much, right? So what you have to do is put parentheses and I minus what you've already paid income tax on. You've already paid income tax on your $9,325 income. So that's the second part, is you have to subtract out the income from equation 1. If you can remember those two things, then you'll get that really hard equation. And that's not easy, but since I've done it so many times, I've come up with a way to remember. You've got to take the total from equation 1 and then subtract out the total income from equation 1. Okay, so there is our equation, our piecewise function. Now we have to answer some questions. I'll graph it at the end when I have more space. How much tax is owed by an individual with gross income of $12,000? So we're given I equals 12,000, and I was just gross income, so we're actually going to use 12,000, not 12. And we're just going to figure out which equation to use. And 12,000 is between 93.25 and 37,950, so we have to use the second equation. So T of 12,000 is equal to 932.5 plus 0.15 times 12,000 minus 93.25. We can use the calculator for that. Okay, so we get 1333.75. So if you make $12,000 in income, you're going to pay $1,333.75 in taxes. This is an input-output problem. Okay. Now this one, it says what was the gross income? What's I, which is your input, if your taxes are $850? Okay, so which equation would you want to use? Well, if you know the total from this top one, 93.25 at income is only 932, you can think through and say this is going to be equation 1. But either you need to do both equations or think through. So because this is an output input, and so it's always harder. You're not really sure which one to use unless you think about it. Okay, so I'll do both. 0.10i equals 850, or 932.5 plus 0.15 times I minus 93.25 equals 850. Here, if I divide by 0.10, don't need a calculator for that, that's $8,500 in income, which is between, you got to check, is that between the two? And we suspected it would be. So that's one answer. If we do this one, I'm going to subtract 932.5 from both sides and get 0.15 times I minus 93.25 equals, now basically some of you are like, oh, I know this isn't going to work, but this is really good practice solving equations. This is a complicated equation to solve. Let me type it in correctly. Alright, and you get negative 82.5. I just want to show you something. You don't have to distribute here. This is times. So you can undo multiplication by dividing and get I minus 93.25 is equal to, take that negative 82.5 divided by positive 0.15, we get a negative 550, which is disturbing, but it's going to be taken care of because we're going to add 93.25 to both sides, and you get an income of 8775. And then check this answer against that domain. I has to be between 93.25 and 37,950, and it is not. So we knew that. The answer to why we knew that can also be, it makes sense when you try to graph it. So let me see if I can graph it here. So here is quadrant 1. All I need is quadrant 1 because income can't be negative and taxes can't be negative. And the first equation, 0.10i, t of I equals 0.10i. And the second equation, 932.5 plus 0.15i minus 93.25. So we can see both of them here. Okay. Notice that I don't want to take a lot of time to graph this. I just want you to look at the slope. If I were to distribute that out, I times 0.10, the slope here is 0.10. Your taxes paid are increasing at a rate of 0.10. Okay, here per dollar. and your taxes here are increasing at a rate of 0.15. So you can see that this has a slightly steeper slope. Okay, so if I want to graph this 0.10i, it starts at 0 because that's what it said to start at, and I'm just going to make a line like that, and then that's the total. We found that that's the highest value. So when x is 9325, y is 935. So I know this is the highest going to be. So this is that when the income is 9325, y is 932.5. All right. So then this one is going to take over right here, but it's going to be a slightly steeper slope. All right, and you could put values in there, but I'm just kind of sketching that graph so you can see. And so when you have a problem like this where you've taken the total from one and subtracted out here, it's always going to end up like this where you're only going to have one answer. So you really didn't need to do both, but I wanted to go ahead and do the equations here. All right, so you have some in the lab manual to practice. Definitely need to practice this. Look at your notes. When you get one like this, take a look back at how we did this one. You'll see other ones like that in the lab manual.